talking about food, right, do you also track other things in the same way, like sleep or exercise?
So I do track sleep. I wear a fitness tracker, and that gives me the sleep stages and respiratory rate, which is important for potentially diagnosing infection before it becomes a little bit of a problem, or diagnosing infection at early onset. This also gives me my resting heart rate, my heart rate variability, and then my average daily heart rate. So some people count steps, but steps doesn't really tell you about the intensity of your effort. So if you've walked 7,000 steps on a flat, on the flat ground versus 7,000 steps up a hill, clearly the up a hill is going to be more vigorous and more of a workout. So I track every day my average daily heart rate for the whole day, which is a measure of exertion. And in some of my videos, I've actually used that metric to try to get after variables that are impacting my resting heart rate and heart rate variability as measures of cardiovascular fitness. So yeah, so then I think what you're asking is, do I do this with supplements? Can this approach be used with supplements? And the answer is yes. And in fact, for clients that I work with on optimizing their blood biomarkers, I encourage them to track not just diet, but to track how much, and how often for each supplement that they're taking. Because if you know your supplemental intake in terms of milligrams or grams per day, and you have enough blood test data, say you have 10 dietary periods with a given supplement or supplements and 10, blood test data, you can look at correlations to see if it's actually doing anything. So, and then you can even tailor that in more by increasing that, so if it's say NMN, right? So if it's 1 gram, maybe you bounce it to 2 grams. Maybe you try a dietary period with no grams. And by having a little bit of your own range, you can start to get at, is it detrimental, neutral, or beneficial? And then even how much should I be taking? So you get towards this idea of personalization through your own data, rather than just following RCTs, taking a standard amount and assuming that standard amount is going to be optimal for you. For me, I keep saying this, but all published studies reduce down to the N of 1 level. The individual has to do a substantial amount of testing at their own on their own self to see if it actually works and how much is beneficial or not. So, and just as a last note, which I left out before, it isn't just evaluating the effect of a supplement or diet on, or physical activity, whatever the variable is, on one biomarker. I see a lot of that too, where, for example, some people in the keto crowd will focus on their triglycerides to HDL ratio and glucose and ignore everything else. So what I've been doing lately in many of my videos is focusing on what I call these big picture biomarkers, which are on the standard chemistry panel. So this isn't some specialized, fancy test. It's a $35 USD test. It's not anything special. Now, granted, I add in other stuff, homocysteine, lipoprotein A, C-reactive protein, which in the US, add a little bit of cost. But so the long story short there is, it isn't just about a few. Trying to get after the correlative effect of supplement or any of these variables on the biomarkers. It's important to look at the full spectrum of these big picture biomarkers, these markers of systemic and organ health as possible. So you can get a sense then of, okay, it's not just improving my lipid profile and glucose, it's also improving my kidney function and liver function, win-win, right? So, because what's the sense of improving your lipid panel and your insulin sensitivity? You're reducing your glucose levels, but it makes your kidney function and your liver function worse, right? So,
right, yes, you have to, because it's the first thing that breaks that's going to cause the problem.
Right. So then the story gets at what is it's like playing with the equalizers on a stereo, right? What is the dose that not just optimizes, the lipid panel and glucose levels, but also optimizes, right, the other ones. But it may not be the highest amount that you're taking, and it may not be the lowest amount. There may be, you can't have the perfect quote unquote lipid panel and glucose level, and you can't have the perfect kidney function and liver function. It's finding that happy medium so that you're minimizing risk across the board rather than only improving things for, 2 or 3 variables. But there's an even higher layer to that too. And this is something that I've learned, and I've only learned it through experimentation. So if you follow only, and my next video and next few videos are going to be on this too. So obviously doing nothing is basically kind of hoping you're going to have health and longevity. And following the published studies is obviously, it should be a higher level, right? If, again, albumin levels are, they decrease during aging and you want them to be higher. So, and then you do all of the things in your approach to keep your albumin levels high, and that approach also positively impacts all the other biomarkers, you would expect you should be okay, right? Or you've minimized risk. But I've learned that in my data, there's an even greater level of specificity there. And that involves looking at correlations, not just between diet, physical activity, supplements, and sleep with the blood biomarkers, but for greater insight, it's biomarkers versus other biomarkers. So just as an example of that, my red blood cells, which are similar to albumin, if they decline during aging and the lower levels are associated with an increased all-cause mortality risk, i.e. anemia. So the reference range there goes as high as 5.8. The lower end of the range is 4.1. 4.1 is trending towards someone who's 80 years old. So you clearly don't want the low end of the range. But for what about the high end of the range? So for me, my red blood cells were about 13 years ago. They declined to about 4.6, which you don't want to have a decline. Again, that's aging for the red blood cell levels. And then over the past 2 years, 13 blood tests, I got them to go back up to 5.1. So based on the published literature for what's found in youth and what's associated with reduced all-cause mortality risk, technically I could stop there. I'm good. What do I need to do anything? I've basically slowed or prevented the age-related decline for red blood cells. So whatever I'm doing, I should stop and just continue on, right? But then I decided to look at the correlation for red blood cells with all of these other 20 or so big picture biomarkers. And what I found was higher red blood cells in my data are correlated with more of these biomarkers, significant correlations using, p-values. This isn't just, it's higher or lower. It's using levels of statistical significance. Having relatively higher red blood cells was significantly correlated with more of these blood biomarkers going in the wrong direction as opposed to in the right direction. So that suggests to me that having values towards the higher end of my range is not optimal. So then it becomes, what is the optimal range for me for red blood cells? I can't just follow the published literature. So that's the highest level, is using your own data to derive. And granted, that's like the most advanced, because you need to have a lot of your own data. I mean, like I said, I have, in most cases, 30 blood tests in order to look at those correlations. If you only have 5 blood tests, it's hard to make those. It's somewhat still guessing, but you need a lot of data. But that's the highest level. So,
like everything in biology is a trade-off. So,
eventually, though, I'm doing it the rudimentary way. I'm not using any advanced statistics. This is I'm using simple correlations, Pearson product correlations. I do it in Excel. I've tried to have more advanced statistical techniques in the past for my training, and I just don't have the brain to code. I don't. So eventually we'll get to the point where there'll be machine learning algorithms. They're already, like aging.ai, they derive the machine learning algorithm to predict biological age based off composite data for a group of biomarkers. And I've reached out to those, that group and others to try to use this machine learning approach to identify the diet that is optimal, that optimizes blood biomarkers and reduces biological age. And, in these machine learning studies, they have 10,000 subjects. I don't have 10,000 data points for blood tests. So they tell me that it isn't going to be possible. So I don't think that's true. Eventually we'll have simplified, algorithms that can crunch all these data, 2,000 plus days of dietary data and 30 or 50 or 60 blood tests, whatever I'll get up to come up with predictions. And then with each blood test, the predictions get better. So, but I'm not using anybody can do this. I'm using simple correlations, in some cases, linear regression models where I'll have not just one variable, but, 2 or 3 variables in the model. And you're looking for is it a linear correlation? I think anybody can do this.
Well, that was actually going to be one of my questions, which is, because you have a PhD. Yes, but you just said like anyone can do this. So you're doing the kind of analysis in Excel. Excel has a regression function.
They do. It's the data analysis tab, and then they have a correlation function and then a regression function. So Yeah, they're very straightforward. Now, granted, I had, I did earn my PhD in physiology, and on some level, well, that helps me in terms of the reading the scientific literature, because that's just so. All right, if we take a step back, granted, it's an experimental based PhD, right? The reason I'm bringing this up, you got to bear with me on this. So, so some people get a PhD in like English literature and they just read books, right? So this isn't what my PhD was. So it's a combination of, being able to read and interpret the scientific literature, but it's also experimental based, where I was in the lab and I did animal experiments and, took muscle and we analyzed mitochondrial function, et cetera. So there's a combination of learning how to read the scientific literature and the experimental side. So in terms of learning how to read the scientific literature, when I first started, it would take me hours to read a single paper. So if you start out and you don't have a PhD, and granted you don't have the experimental experience that I've had, and I'm not saying that trying to flex, just know when I started, as I mentioned, it was very difficult for me to read scientific papers. I mean, I had to look up every term. I didn't know what I was reading. It was like learning a new language. But the more scientific papers you read, eventually you get used to the terminology, the vernacular, et cetera. And then I just jump straight to the data now. I don't even really need to read the paper unless I want to see how they rationalize the given finding or whatever. So the PhD helps me in terms of the scientific literature. So I try to take that expertise, quote unquote, of being able to read the scientific literature and distill it down into easy to understand videos, so that if someone wants to know what's optimal for glucose or albumin or creatinine, et cetera, you can just go to my video and see that I've done a literature review, a comprehensive literature review, looking at the largest studies, which should have the most, the most application to the wider population, trying to make it easy to understand as quickly as possible, rather than having to struggle for 2 or 3 years trying to read the scientific literature. It just may be, too time consuming and too difficult. So in terms of, I try not to, hide behind the PhD, and I want to make this easy and accessible to everyone, so that everyone can do this on their own. Now a company may evolve out of this, and I'm working with, some groups are along those lines, but I want empowerment. I want people to be able to do this on their own level, to be able to interpret their own data based on the published studies, to use their own biomarkers in correlation with their other biomarkers to see what's optimal for them. I don't want this to be, hidden behind, education, someone's education and expertise, where you've got to pay exorbitant, sums of money in order to optimize your own health. I want to make this easy and freely accessible in terms of the information for people to be able to do it. So yeah, then I use Excel, and what is the optimal approach can be debatable. I don't see any other way when you have dietary data and you have blood test data, just as examples. It could be physical activity or supplements, et cetera. When you have that data, how do you look to see if those data are related? It has to start with a correlation, right? Now, is that correlation significant, statistically significant? That's a different story. I mean, I've had, some people, comment on my videos, and one in particular, Max Eastwood. And if he's watching, props to him, because these are challenging questions. He'll say to me, you have to adjust your data for multiple comparisons. So basically adding an additional layer of statistical expertise. But I encourage, people to criticize. I think it's good for the field. And look, if my approach in using correlations and simple statistical analysis isn't optimal, someone will come along and use a better statistical approach and improve upon how I've started this. And, I'm more than willing to follow someone else that has a better approach. So, but it can be done with, relatively easy statistical tools. It may take more time and data to get closer to the truth. But I mean, I look at this like a crossword puzzle. Each data point, each blood test data point is a puzzle piece. How many puzzle pieces do you need before you start to see the picture in terms of, this is the optimal diet for me, this is the optimal level of physical activity for me, this is the optimal level of supplements for me? How much data do you need? Is it 1 blood test a year? I don't think so. Is it 60 blood tests over 6 years? Maybe.